Hello, I'm Jorge Garza, and today I'll present to you Appliancizer, a tool that can transform web pages into electronic devices. With the arrival of smartphones, electronic devices that combine both graphical and tangible interactions have become more popular. However, prototyping smart devices' graphical-tangible interactions remains challenging and time-consuming. This is due to the complicated development steps required to connect both graphical and tangible interfaces. Our research has found that designers make use of graphical elements as mock-up hardware components to simulate the tangible interfaces of smart devices. In the image, we show a simulated interface of a smart thermostat designed on a web page by the web developers community. In the example, the HTML elements inside the green box are used as mock-up hardware components to control the HTML elements inside the red box that simulates the device screen interface. We call web applications that contain HTML elements used as controls to simulate graphical tangible interactions web-based prototypes. Following the idea of web-based prototypes, we created Appliancizer, an IDE that not only facilitates the simulation of graphical tangible interactions, but also allows developers to transform the HTML elements used as controls from a graphical to a tangible interface. To make an electronic device with Appliancizer, users start by adding a web-based prototype of a smart electronic device to the IDE. Our tool provides users with a code editor for creating web-based prototypes of smart electronic devices. Multiple web-based prototype demos are included in our tool. In this example, we load a smart thermostat web-based prototype demo. Our tool supports 3 HTML controls that can be used as mock-up hardware components. These are button, span, and input type range. Each supported HTML control can be replaced by hardware components models that encapsulate circuit specifications and share a similar interface, also called tangible controls. In the web-based prototype button, HTML controls allow you to set the target temperature of the smart thermostat application. An input range ladder HTML control simulates the ambient temperature. A span HTML control simulates when the cooling compressor is turned on or off. After testing, we proceed to add the web-based prototype to a virtual screen display area that simulates the device screen content. Our tool will highlight with a green dotted border all HTML controls which interaction can be transformed from graphical to tangible. Appliancizer helps create a clear separation between device screen HTML elements and HTML controls. HTML controls can then be drag and drop from the virtual device screen to a virtual PCB shown at the right. At drop, tangible controls that match an essential interface similar to the drop HTML control can be selected. Since both HTML controls and tangible controls produce the same events, the smart device tangible interface can be simulated, therefore allowing for an earlier exploration of smart devices' graphical tangible interactions. Once the device is ready, Appliancizer can automatically generate the PCB and low-level code required for the device. The generated PCB sits on top of a Raspberry Pi computing device. A custom OS allows users to access the web application using a web link. On load, our custom OS removes the HTML controls from the screen in a process we call hardening. Now the same web page runs in our automatically generated device, with parts of its HTML DOM reacting to physical inputs. No changes to the web application source code were required. Other complex devices can quickly be prototyped and built. In this example, we show a physical video player made from a web page. To transform HTML controls interaction from graphical to tangible, we introduce a technique we call essential interface mapping. With this approach, HTML controls and tangible controls are mapped together by the most essential data they produce. Tangible controls encapsulate hardware component specifications, such as schematic information and low-level code. Then, similar to hardware description languages, selecting different HTML controls and tangible controls allows the generation of varying types of electronic device designs. We asked 2 developers to design the same smart thermostat that we demonstrated earlier. Both developers designed the PCB in an average of 4 minutes. Appliancizer allows rapid prototyping of smart devices by providing 1. Earlier exploration of graphical tangible interactions. 2. Automation of the PCB design workflow. We also believe that Appliancizer opens the doors for web developers to design smart devices. Thank you.